Hi, it's Tim from ORACLE-BASE.com. In this video, we'll discuss how using bind variables in your database applications can improve performance and protect against SQL injection attacks. When a statement is sent to the server, a lot of work has to be done to process the SQL. For a new statement, all the SQL processing steps have to take place. This is known as a hard parse. For statements that have already been parsed and are in the shared pool, some of the steps can be omitted. This is known as a soft parse. Since a hard parse requires additional CPU compared to a soft parse, we tend to look at high rates of hard parsing as a bad thing. In transaction processing systems, we often see the same SQL issued many times, so soft parsing can result in a considerable performance improvement. When we concatenate literal values into a statement, the database sees each variant of the statement as unique, so each time a hard parse occurs, and a new statement is stored in the shared pool. This wastes CPU and floods the shared pool with similar statements. In contrast, bind variables encourage soft parsing and streamline the shared pool contents. Here we've issued two similar statements. They only differ by the literal value used. We check the SQL area view and we can see two statements in the shared pool, each with a single execution. In this example, we're using an SQL-CL bind variable to simulate what you might do in a programming language such as Java or C#. We define a variable and give it a value. We issue a query, but this time we use the bind variable instead of a literal. We set a new value for the variable and issue the same query again. Now we see a single statement has been added to the shared pool, with this statement having two executions. So by using the bind variable, we've saved CPU by taking advantage of a soft parse, and we've not wasted memory in the shared pool by filling it with similar statements. In addition to the performance benefits of bind variables, they can also protect us from SQL injection. The following examples use dynamic SQL to mimic what developers do in languages outside the database. This is not how I would expect to see PL/SQL used normally, as static SQL would work fine for these examples. In this block of code, we have a variable to hold a username. We set it to the value Smith. We concatenate the username into a string to create an SQL statement. In this case, it counts how many employees have the name Smith. We use dynamic SQL to execute the query and display the resulting count. We can see there's a single employee with the name Smith. This code seems to work fine. We repeat the test, but this time perform an SQL injection attack. Rather than using a normal username, we set the username so it closes the quote and adds a new predicate, or 1 equals 1. When we run the code, we see 14 rows are returned. We've used SQL injection to alter the running statement, allowing us to get additional information. If we check the SQL area view, we see the statements that were run. We have the type of statement we expected, along with the SQL injection attack where we altered the SQL. We alter the code to use a bind variable instead of concatenation. We set the username variable to the value Smith. When we run the code, we get the expected output. Let's try to use an SQL injection attack. We set the username to the sneaky value again. This time we get 0 rows returned. If we check the $SQL area view again, we can see why. We have a single new statement added to the shared pool with two executions. We're not able to alter the SQL statement. Instead, we just search using a bizarre username. If you have a situation where using a bind variable is difficult, you need to sanitize any input values to make sure your code can't be attacked. Oracle provide the DBMS assert package to help. It contains several routines, but in this example we'll use the "literal" function. The code looks similar to our original example. We're concatenating the username to create the SQL statement. This time, rather than just setting the username variable, we'll also call "literal" to handle the additional quotes for us. When we run the code, we get the expected output. Let's try and attack this new version of the code. We set the username to the sneaky value again, but this time "literal" throws an exception. We can see a numeric or value error has been thrown. In real code, we would of course trap and handle this exception. The important point is, "literal" protected us from the SQL injection attack. So in summary, bind variables reduce CPU usage by reducing unnecessary hard passes. They streamline the shared pool by stopping it from getting filled with similar statements, and they protect us from some common SQL injection attacks. Thanks for watching. As always, there are links to articles containing lots more information about this subject in the description box below.